that. But that's in short answer. Minikube is a solution for you, where you get a one VM through the Minikube and the master and worker and everything you have in the one VM only. Fastest way you can get started. Minikube.
Yeah, because in Dell, right, it's more of a Windows than the Linux, right? At least the local machines.
Yeah.
Okay.
Now I'm going to talk about. Here you have to ask Kubernetes. Kubernetes is asking you, what do you want? So these guys should know what he should expect from the Kubernetes. And when I say Kubernetes, that means API server. So now I want to know what API server can offer to us. So that I don't know. So what I will do, QCTL, I will write it. And so many commands are there, guys. You have to go one by one and check it out. Now this command will tell me what this version of Kubernetes cluster can offer me. So I will go and check this command in API server. Now this view, let me little reduced so this it can accommodate the the screen and the screen. Now you see here, these are the resources which API server can give it to you. These are the resources. So you have a list left side name of the resources, short name, which are the versions which is they have released as part of this Kubernetes cluster. This is the one keyword which you call it a namespace true and false, and kind is equal to binding. So these are the case sensitive things which you specify in the YAML file. So if someone will ask you, okay, which are the resources supported? These are the resources supported. That means these are the things you can do at Kubernetes. That means you can request to the Kubernetes, out of which some of these things I talked about it. This is the pod. Now a little bit of the pod, you know that, right? Pod is one of the resources. Node, the one which I showed you, worker node on master node, node is another resources. So like that, I'm going to teach you so many resources. Which are those resources? So I'm going to teach you pod. I am going to teach you. I'm going to teach you replication controller. I'm going to teach you deployment. And I'm going to teach you last one, service. So now you will say, Rajesh, what exactly this is? So I wish if you know some cloud, I could have created a correlations immediately. Remember that this is the Kubernetes platform. Okay, and this is the AWS platform. Let's correlate actually. So here, if you want to correlate the functionality at a high level, I might not be perfect 100%, but maybe just to correlate in your mind, namespace, you can see some. See, AWS region is huge, right? But how do we isolate the resources? Resources means one, you have account, I do have account. I create a VM, you also create a VM on AWS. How do we isolate? We have a VPC, correct now? If you want to talk about the pod, so here EC2 instance. Talk about the replication controller, then auto scaling, you can correlate that. This is also auto scaling group plus many future features are there. Service, if you want to correlate at AWS, network load balancers. Just correlating for your mind actually. Okay. So what you do on AWS, you create a VPC, then you create an instance, then you create an auto scaling group. And then if you have a too many EC2 instances, you create a load balancers. So access that through the load balancer. Something similar you can do in the Kubernetes also. You can create a namespace pod, replication controller, deployment and service. Are you able to understand that at a high level? All of you. So the question is, what is a namespace? Namespace which you can see here. This is the resources I'm teaching you here. Look at this. And here you see, these are the resources, some of the namespace true, some of the namespace true, false. So what is that? So guys, understand this way. One simple use cases I give it when I talk about the namespaces. That is probably will help you to understand. So this is your clustered, but powered by multiple worker. Worker 1, let me change the color. So worker 1, worker 2, and worker 20. It can be multiple worker. So here multiple worker is powering this clustered, and this is the one clusters you have together. So now, you know what? This is the project 1. And this is a project 2. So now, you know what, when they deploy the pod, so this pod, some 3 pods, let's say they deploy. So one pod will be created here in this particular worker. One pod will be in this particular worker, and one pod will be in this particular worker. Now P1 also, project 1 also deploy the pod. So 3 pod. So 2 projects, 1 cluster. 2 project, 1 cluster, maybe 10 project, 1 cluster, maybe 50 project, 1 cluster. Yes, 1 cluster. You may have a production server, 1 clusters, and 20 product line you are running on that. It is possible, right? So yes, that is possible.
So Rajesh, one way we need to understand here is, so you have one pod which is running 2 Docker containers, correct?
That I'm not worrying about it. That I'm not worrying, but I don't
so
care.
What is red? What is red and what is green here?
This is the 3 pod for the P1 project, 3 pod from the P2 project. Simple. I'm using 3 because of some visualizations. It can be 3000 also, no problem. Got it? So what I'm trying to say, one cluster can be shared by the multiple teams, multiple departments, multiple projects, multiple people. So now the question is, see, when we start sharing, the fight will happen. Fight will happen between the 2 projects. So one cluster, too many projects in your organizations, you have it. And the question is, what kind of fight will happen? So one of the fights I'm going to talk about it. Tell me this, I'm asking this question, okay? So let's say red pod, there is some bug. And that bug is doing, you know what? They're consuming the resources more. The moment you deploy that pod, it's consuming too many resources. But tell me one thing, will it impact the project 2 also or not?
If it's in the same cluster, it will impact.
Yes, how? Which way?
Because it will use the same memory, right?
Right.
Same
Yeah.
CPU.
Yeah. So now you see this pod is running in this worker, this pod is running in this worker, this pod is running in this worker. So this has a bug, so it will impact this machine, this machine, this machine. And now P2 projects are very angry and frustrated, saying that how dare you are running the applications without a proper testings, consuming lots of CPU and RAM, and because of you guys, we are also down. Okay, that was an incident. Second time, what has happened? Project 2, there is one engineer. What he did, because all of us were working in the same cluster. So by mistake, they modify or deleted or anything as such with the P1 pods. Now P1 project is very furious on the P2. Now say, how dare you touch my pod? You should know what you are modifying and all. So what I'm trying to tell you at a high level, you have one cluster, multiple projects, fight will happen. You cannot stop it. Fight will happen over the access of resources. Resources means, when I say resources means CPU, RAM and storage and network, okay? And access issues also. So the question is, how do we deal with it? How do we deal with it? Because if you vertically divide, let's say create vertically divide, then you have to have a 3 clusters. 1, 1, 1. Correct now? Hello?
Yeah.
So I can do one thing. I will not vertically divide. I will divide horizontally. So I'm saying, hey, let's do one thing. Let's create one area, and that area we call it namespace. So this is the namespace and this is the namespace. And what I will do at the namespace level, I can set, let's say there's a 5 GB, 5 GB, 5 GB, 15 GB we have. So I set this, no matter how many pod you run in this particular namespace, you cannot use more than 7 GB, and this product cannot use the 3 GB, no matter how many pods you are running. So here, this is a red pod you are running in this namespace, green pod is running in this namespace, and maximum what you can consume is 7, and 3 still you have a 5 GB RAM. Can you do something like that? Resource allocation at the namespace level. Can you do that? Yes. So Kubernetes allows you to create a namespace for what? Isolation of resources, multiple projects and all. Now, next thing what you can do for this particular namespace, you assign this access only to this guy, and this is the admin of this project. You assign only to this guy. That means this guy cannot do anything in the next namespace, and this guy also cannot perform any other operation in this. That means security, namespace level access you are giving it. And apart from that, there's so many benefits out of it. So what is the namespace? Namespace is a logical division of clusters. For what? Managing the resources. Resources means CPU, RAM, storage, and access. Understood, guys, all of you?
Yes.
Yes. So now then many people have started coming and saying that, hey, yeah, this is a good idea. But. So then Kubernetes says, hey, listen, I'll tell you one, things which I did not never told you actually. This all application which I was talking about, you know what? This is nothing but a pod actually. Yes, these all are application, but running in the pod itself. Correct? You want to see that? Let me show you that. So go to kubectl get pods hyphen all namespaces. See here. See, I told you one API server, etcd, controller manager, scheduler, 2 proxy because 2 nodes are there. Core DNS 2, you have it. This is fixed for clusters. This is the networking related pods. Other pods. So you know what has happened? Kubernetes says, okay, we designed the namespace for you guys, so you can distribute the resources and access. So we are also running the pod. So let me do one thing. Let me create one more namespace, and the name of the namespace will be kubesystem. Then people started talking about, okay, what about those belongs to no namespace? So where they will create a pods? Then the Kubernetes created one more namespace which is called default. That means the pods which belongs to nowhere belong to the default. Then many people say, hey, okay, there's some pods you want to run common for the multiple projects. So no one wants to host those pods. So what to do with that? Then Kubernetes created one more namespace which is called public. Then administrator of Kubernetes came and said, hey, we are doing log monitoring, infra monitoring, trace monitoring, this, that, and all maintenance work, and where we will run the pod. So Kubernetes said, okay, no problem. We'll create one more namespace pod, node. So in that case, if you see that here, I did not create any pod, right? Any namespace right now. These are the namespace which you have available. So default, public, system, and node. So these are there, and I can create my own also namespace. And at the namespace, you can limit the resources, what maximum you can use it. So now coming back to this question, if you see that here, all the resources. So now what is the namespace true and false? So understand that pod can be created where? Inside the namespace. So look at this here, pod is namespace true. And here node, this is the node. This node is at the namespace? No, it's at the cluster level. So that's where the node is false. So that means any resources which you can create in the namespace is namespace true, and any resources which can be created at the cluster level, that means the entire cluster will share, that called namespace false. Understood, all of you?
Yes.
Okay, so now the question is what to do. So guys, these are the resources you need to learn and then create. So I'll teach you one magic formula for it. So here I told you, right? server, you have multiple APIs. What do you do with the APIs? Each API? How do you call it? How do you call it? All of you. So there's a HTTP world and there's a programming world. Tell me both way. Programming world. Anyone or one of you have worked with the API level?
Yes. How to
So what
define
do you do?
API and access API?
So any API you should develop, you have to create a 4 function at least. That is called create, read, update. These 4 function, update or edit also, these 4 function you have to create. This function should be there in that API. So remember that these all are API, pod is API, namespace is API, everything what I'm showing you in the background, these all are API maintained by API server. So what you do, create, read, update and delete. In HTTP verb, what we say is put, push, get, post and delete. This is the HTTP verb, right? All of you? Yes, so this is the magic formula. Any API resources which you see it here, you do nothing but create, read, update and delete CRUD. So what to do? Create pod, create namespace, create a node, create RC, create deployment, create service, create this, create that, read, update, delete that. So there's a 2 ways. One is a command line, one is a YAML file. So for each and everything, you have a command line and YAML file. Command line and YAML file. That means I taught you the pattern. That means this pattern you can use it with any API resources which you can see in the background here. Okay, so there's a pattern. So this pattern, the command line, I don't know actually. So I will ask kubectl, hey kubectl, give me that all this pattern. How can I work the command line? YAML, I'll teach you. Command line, you will find it out. So tell me which command is for the create the resources, any resources. Guys,
it is a create, right?
Yes, create. Yes, you have it. So the command is create, and I'll give you the YAML solution. Create YAML file. That's all. Very simple logic, and it's work for the everything. Read. Tell me quickly.
Get.
Yes, you have it. So get, and so you're learning yourself. I'm not teaching you. Get -f YAML file. Okay, update.
Edit.
Edit. Hi, and here this I'll teach you. For this apply -f. Okay, apply somewhere downside. Okay, and delete. I think by now you know that. Here it is. So delete and then YAML file delete -f. Delete -f YAML file, and this is also. So it's so easy, right? Pattern is so easy. Don't complicate yourself. That means what I'm trying to tell you guys, any resources you can do the CRUD. Simple. Either command line or YAML file. Very simple. So now what should I do? So I'm going to create a namespace first, but through command line. So can I do that? Let me show you your CRUD. Remember, I'm only following the CRUD. So what to do? kubectl get ns. These are the ns. Can I create ns? Shortcut. NS, what NS? So namespace for the dev, namespace for the QA, namespace for the Rajesh. I created a lots of namespace and get NS. I got this NS. So these are the namespace you created, and now you'll apply the limits for the CPU and access. But right now I'm not complicating it too much. For understanding purpose, that was okay. Okay, so these are the 3 namespace I created. Now I get it also. Can I modify, edit? What namespace? Which namespace, Rajesh? Now what to modify, what not to modify? I think with the experience you get it, but label is my fab. Always I modify. Tab, not use it. I mean, use always space, it's YAML file. And what is this? This namespace. So it's a team belongs to what? Personal. This is my personal namespace. And I created this and this get ns. Yes, describe. There's a command called describe. And ns, which name is Rajesh. And you see that where is the label? Here it is. There's one command also you can check, this get ns and hyphen show label. There's so many of combination of the command. Slowly you will get it. Understand the idea. Commands anyways you will come, you will become confident with the practice. See that. So here Rajesh, add it. And can I delete that? So yes, nothing great about it. Delete what? And spelling mistake, I guess. Yeah, delete ns and what Rajesh. And I deleted this. So I just did the CRUD. It was so simple. And like that, for the each resources, you can do the same thing. CRUD. See the Rajesh is gone. So did you understand the secret formula for working with the each resources? All of you.
Yeah.
Okay, so namespace is done. Now what is next? Pod. This is important, right? Pod is important. So this time I'll show you the demo through the YAML file. So for that, you can come back to my website and type pod example. Okay, for each and every examples I have it, but you can take it from the official website also. There's no problem. All the codes are same actually. Okay, so this is the YAML file for the pod. I just copied something. Okay, just again, hold on. One of the YAML file. So here I'm asking, see here, kind is equal to pod p capital, right? You see that? So if you see that here is coming from resources into here. This is the p capital, kind is equal to pod. This is case sensitive. So that's the reason kind is equal to pod. So now what is this? What do you want? I want pod. Okay, which version of API? V1. What is the name of the pod? What do you want to label with? What contains container? Where's the containers? Multiple containers. S, remember S. First container. What is the image? Name of the container running with a port number. You want more container? Different image. NGINX. Port has to be changed. This has to be run different. This has to run different. So like this, you can want multiple containers. Did you understand this? Port specifications? Yeah. Simple. Yeah. Practice will make you perfect. So don't worry about that. So here, let's go ahead and so here vi pod.yaml and enter. And this is the YAML file. And what to do? I think you know that. kubectl get pods. This is in a default namespace. If I want to see that, work with it, always use the -n, means different namespace. Remember that Q namespace, default namespace. Right now I'm working with the default namespace. That means I will not specify again and again this one. Many ways to work with it. So get pod default namespace. There's no space. So can I create it? So kubectl create command, you know that create -f. What is this? Pod.yaml, enter. Now you have a pod. So this is the pod. You got it. You can see the different view, show labels. -o, white IP address of the pod. Here it is. You want to curl http dub and see here, welcome to Devops Tool version 1. This is the image of mine. So this is the pod. So what to do? So I did the create, I did the read, and then after that editing the pod. So what to do? So there's so many ways to edit the pod. You can online also you can do that. So here get pods and edit. This is the command line, edit pod, which pod, this pod, and edit. Now what you want to edit? Slowly you will get gradually the learnings, but right now labels is my fab, and here this pod application or environment, this is dev. So en and dev. I modify only the labels. I'm playing with the labels and save it. And now can I see that labels is modified or not? And you see that environment dev. So I edited it also. If you want to edit through the YAML file, no problem. Modify this YAML file and add something here. Team, and this belongs to XYZ team, and save it. and apply kubectl apply -f pod.yaml and done. And there's some warning that you can ignore it for time being and see that team XYZ. So I can modify directly on the etcd or YAML file and apply it. And then finally, what you're going to do? So CRUD, last thing, delete. What do you want to delete? So I want to delete the pod. Which pod? This pod. And enter. And you see this pod is nowhere can be found. So guys, this is the pod. I did nothing, but I did the CRUDing the pod. So now next question you'll ask me, Rajesh, okay, you did the CRUD of the pod, but how to use it? How to work with the pod? So that is where I will ask the kubectl. Hey kubectl, please tell me how do I work with it? And that's where they have given you so many commands which we call it, where is this? Troubleshooting commands. Yes, this command to work with the pod. So this I'll just remove it, auth I'll remove it, proxy I'll remove it, and this command. What to do without? So you can describe the pod. You can see the logs of containers of that pod. You can go and attach the containers. You can attach to the console of the containers. You can go inside the container and run any executable. You can access the container from outside. You can copy some of the files to the containers. Remember, I am talking about the containers, and stuff like that. So that means these are all commands to get into the container. So let me do that quickly. So here, do we have any pod? So actually I don't have any pod, so I'm going to create it. So create -f one.yaml. I created it. So now you have a pod. Pod is created in the worker node. Remember that. So now what to do? Describe this pod. So describe and the pod, which one? And this pod, it can be any other resources also. This pattern I'm teaching you, remember that. So here you have it. Now, please spend some time, 10 to 15 minutes, whether you understand or not understanding, please spend some time and go through this. Here you have IP address for the pod. Everything you have it in the pod. Now what you want to see the logs of the pod. So I don't think so you'll have a logs because I have not accessed this. So let me see that logs, which one? This pod, and you see there's no logs, but I want to see certain logs. So let me go and get the IP address of it. I'll use the containers and the pod, then logs will be generated automatically of the containers. So this is the curl. I'm hitting that this pod IP address 1 time, 2 time, 3 time, 4 time, 5 times, and all stuff like that. I did this, and then after that I'm going to see and the logs. So see the logs of the container of that particular pod and stuff like that. Do you want to see the console of it? So attach of the container of that particular pod. Attach. So right now the one which you see is a HTTPD console actually. So if someone hit it, you will see something similar line. Okay, Control C. If you want to go inside the container of that pod, yes, we can do that. So here you can run using exec command. You can run any executable inside a container of that particular pod. For example, ls. Where is running? Do you think it's running in your host machine? No, it's running inside a container. So this is the file system of the container. Can I go inside a container? Yes, you can go inside the container in the interactive mode, IT and bin bash, because we are human being. We always work with a shell. So right now I am going inside a container. You see that? Where are you? Tell me, where are you?
Inside the container?
Yes, inside a container. You see that whatever you are seeing is inside a container. Exit. I'm inside the host now. I'm in workstation line. Okay, so this is the way you can do that. Now, how can you access the container? So basically, if you're inside a container, which I am, I can access to the IP address of the pod. But if you're outside, then you have to port forward it. Understand this. This container is running inside the cluster. So people are outside. Then how can you access? They cannot access. So for that, you have to use the port forwarding. There are few discussions required actually, but I'm not doing it because of in the favor of time, but I'm showing you the power of Kubernetes. So how can I do the port forwarding? Let me do that, and rather than talking. So here, to be honest, I don't remember the command. So what to do? qctl port forward -h. This is the magical command, and that a lot of examples are there. And one of the examples I'm going to pick it up, which is here. Okay, so this command will help me. And so here port forward address from everywhere. Which port? So port name, it should be name, it should be here. Is the pod name, and pod is running with the which port you want to expose with? Node port 8888. Container is running with which port number? 80. Okay, so go ahead, clear the screen and enter. Now port forwarding is happening. That means if I hit on the IP address of node, worker node or master node, any node, and the port number 8080, I can access the container. So can I do that? So IP address is here and the port number 8888. So here, see, there's nothing available but port number 888. Sorry, port number 8888. Bad port number here, and you see that it's not coming. Let me check the port number. 8888. Did I make any mistake? Oh, sorry, 8888. Yeah, that's correct. I think I made a mistake in the placing the port number. So this is the container port number. No. This is the node port number. I know that for sure. And this is the container port number. So container port number. This command is correct, I think. And let me see that container is running inside or not. So here what I'm going to get. First I'll hit this container locally inside from inside a cluster. So HTTP and enter. Now it's accessible. There's no problem in it. So what mistake I made? This is the host port number. Let me change the port number. 8000. Okay, so let me change this here. And here 8000 opposite. Last command was correct. This command. Let me check one more time. So what I'm doing right now. Yep. So the command which I used is. This is the correct command actually. So. One more time I'm copying and pasting. And port name from everywhere 8080, and then container is running on 80 port. And this is the command. I know that this is a correct command. 8888. I should be accessing that applications. 8888. Okay. I understood. So this port forwarding I'm doing at the master level. So I should be accessing at master level. That's my mistake. Yeah. So it's a dedicated to the host actually. Yeah. So yes, 888, and you have it. Got it. So that was my mistake. So I copied by mistake the worker machine, but I'm forwarding at the master machines. Yes. So this is the port forwarding commands which you can use it for the next other things. If you want to copy some files, you can use this CP commands. So now I taught you how to work with pod. Any questions? Any doubts you have? All of you?
No, it's good.
Now what else? So next resources which I'm going to teach you, this is called replication controller. Now, what is a replication controller? So guys, understand that. Do you really want one pod? No, of course we don't want one pod. So we want too many pods. You have two things. Understand that. This replication will replicate one pod to many pod, and this controller will make sure that desire always. That means if you desire 3 pod, it should be always 3 pod. If you desire 5 pod, it will be always 5 pod. So this is the replication controller in simple way. So now the question is, how can we create? So let me show you here. So let me go to my example replication control. Enter, and I want the examples code actually. So I think this is the which will help me. So this is the one of the YAML file which I'm going to use it for this demo. So what do you want? So this is a comment, I'll remove it. This is a comment, I'll remove it. So what do you want? Replication controller. Which version of API? V1. What is the name of the replication controller? This I'll just name it RC because it'll be easy for me to use that in the command. How many replicas of pod you want? 3. Do you have some labelings on all for the each pod? Yes. Do you have a specification for the container? Yes. Which container? This one. So that means each container of that, each pod, you will have this container. So 3 pods, each will contain this container. Each pod will contain this container, and this is called replication controller. So can I create it? So I'll just call it eirc.yaml and enter this one, save it. And what to do? CRUD. I think I'm not going to teach you. What is that? CRUD, which I told you. So here RC. Look at this, get RC. Now I'm doing the get RC. Which RC? You see, you have one RC, desired 3, current 3, ready 3, and now you have a 3. Now edit RC. So you can edit the YAML file also. You can edit through the command line also. Now you are comfortable. Edit RC. Which RC? Name of the RC is this one. And what you want? So I want the labels. I have done it. Now I'll do the replications. Replicas. Where is the replicas? So replicas here 3. I want 5 now. Save it. I think I modified wrong entry or what? No, I think I modified the wrong info. So where is the replica? Can you see that replicas? I think it's drop here 5 and 5. I want 5 pod now. See, you got a 5 pod. Now, can I want 1 pod? So here edit and go for 1 pod, and you see that RC1 pod, you see that all the remaining pods getting terminated. Here. Can I got 10, 20 pods, 2000 pods, 3000 pods? You have it. 20 pods. Save it. Done. See that 20 pods got created. It's in pending now. Will be created. See slowly one by one it's created. Understood, all of you?
Mm-hmm.
This is called replication feature. That means you can replicate as many pods you wanted within a second. But it has a controller feature also. What is a controller? Let me show you. So here, right now, 13 pods you have a total, but I don't have a patience to wait for the 50. So I'll just reduce this to replicas to 2. And here all the pods will get terminated. You see that here, 2. And get pods. See that everything got terminated except 2. Let it happen. So this is how you can replicate it. So now you have a 2 pods. And can you look at this timestamp? This is created 2 minutes before, 15 seconds before. Now I'm going to show you the power of controller. So what is my desire? My desire is 2. How many you have it? 2. But I will do accidental deletions. So this command, I'm deleting this pod and this pod also. Delete it. Manually I deleted. Look at the age. And you see that. Did you notice something?
Oh yeah, it added again.
Yeah, I told you, Kubernetes will do everything for you. So this is the replication controller. Okay, so now what next? So next one is deployment.
Rajesh, 1 second before you're forwarding, right? So, for example, like we have created a number of pods, right? So, in real time, like we may have randomly any one or two pods might be resulting in errors, like the health of the pod like might got worse, and those pods started resulting in errors and exceptions, and they are not responding to the requests.
Right.
So, in that case, how can I control or how can I make that pod uh, auto restart or
Yeah, so
delete it
each,
automatically?
so that's the beauty about the pod. Each pod, you know what, you can set the health condition. And if these conditions are not matched, those pods will not receive any traffic. And those pods will be replaced with a new pod. So if health is not good, automatically they will get terminated and will be replaced with a new pod. And one more thing, there is a service which I talked about it. Look at this here. Network load balancer means service in Kubernetes. So this service only load balance the healthy pod. So health definition you can define in the pod observability. By the way, I'm just using the small file right now just for the demo, but it can be pretty long actually. Hundreds of ways you have it to make the maintenance of the health and the availabilities. So this area we call it a pod observability. So you have to set those stuff.
Can you please share like a few basic things and which we can handle this?
Can you tell me the example of it? What exactly you're looking for it? Because I said hundreds
Yeah,
of
for
things.
example, like the scenario I explained, right? So if pod is not healthy, don't want to take traffic to that. And
So,
also I don't want to go down with the number of pods.
Yes, readiness. Readiness actually. Okay, I'm showing you. See here, how to check containers readiness inside the pod using readiness prop. So this is the check you have to do. As I said, right? In the pod, you have many things. So right now, this is C. What you have? Pod. Which container? So this is the container. Now here you have to set this things. So if it is healthy, then it's okay. If it's not healthy, then we'll get terminated. So these are the readiness check. You have to set it up. There's
Can you paste this link?
Yeah, there's a one more keyword which we call it readiness prop and liveness prop. So I'll show you this one. Liveness and spelling mistake I guess. Or liveliness. This is the right spelling.
So Chandra, I think to answer your question, right? Maybe Rajesh can pitch in here. Now, whenever a pod becomes unhealthy, right? That's it.
Yeah.
It'll get terminated.
Yes.
Then the job of the replication controller, because you are setting up the number of instance there, right? Number of pod instance. So it'll spin up one more, right?
Yes.
Let's say one thing gets unhealthy, it'll spin up one more pod.
Yes. And you see that here. See how many desire to, how many current to, but how many ready. That is important. Ready means healthy.
Yes.
Got it. And always traffic get into the ready pod, not like a running pod or current pod or whatever. It should be ready. How to set the ready? So readiness, just now I should send the code, readiness and liveness, that you have to write the condition for it. Okay, understood at a high level now?
Yeah.
Okay,
thanks.
let's
This
move.
Helps. We'll go and cross verify like what is there in our configurations.
Just write down one more keyword which will help you to create a very sophisticated pod specification, and that topic we call it a pod observability. It's basically a development course actually in the Kubernetes domain. So pod observability is one of the best thing you to know about it. If you're in a development team, you have to do all this stuff. Okay, so guys, now next API resources, which I'm going to talk about deployment. Let me tell you here, this is the most popular API resources which we use to deploy the pod. most popular. There are so many other resources also there, but this is the most popular. So now you will say, what is a deployment? So guys, you know what? In a deployment, we have a feature of replication. Yes, this is the same thing which I have here. And then we have a feature of controller also. Then you will say, Rajesh, then why do we have a duplicate one? We have a replication controller also, same feature. Deployment also, we have a same feature. Then you know what, guys? Replication controller has certain bugs. Yes, replication controller has certain bugs. So instead of developing the V2, what Kubernetes did, they developed the bug fixes. They did it in the one UPI API resources, which we call it replica set. That means replication controller, all the bugs has been fixed in the replica sets, and replica sets is used by deployment for these two feature. So then you'll say, Rajesh, then why we are learning deployment? Because I can learn directly replica sets also. And this got deprecated, actually not removed, deprecated. But you know, guys, here you have beautiful things, the many beautiful features available in the deployment, such as versioning, such as rollout, such as rollback without even a single millisecond of the downtime. So these are the feature, which is a superb feature, very powerful feature. And for that, we use deployment, not replica set, because replica set will give you only two features, whereas a deployment will give you multiple features. Unfortunately, I'm not able to talk about each and everything, okay, because of problems with the time. But I think you know my pattern right now. You know my pattern right now. This is the deployment strategy. I want you to read it in the Kubernetes. And this is also, I want you to read it. And this is the something I want you to spend some time and roll out, right? So Kubernetes roll out. I think these are the one. Okay, so you can check it out. These URLs it will help you to explain all the feature. But right now I am creating only this. I'm using it. So let's get started with it. This time I'm not going to use the YAML file, which I did it with a pod and RC. This time I'm going to play with a command line. So now the problem here is I don't know the command for the deployment. Then I will ask the Kubernetes, hey Kubernetes, please give me the command. So here create deployment. So -h, remember the secret formula. So here, what are the things you can create? These all are the things you can create, out of which deployment also you can create through the command line. So deployment, deploy in a short, okay, we use it. And here, these are the examples. These are the options. You have it. So what you want? I want to deploy. So let's deploy something like this. This is the simple command. I just copy it, pasting, and what to do. So I'm going to use my own image. So here, kubectl create what? Deployment. What is the name of the deployment? Which image you want? This image I want. How many replicas you want? 3. And kubectl get deploy. There's no deployment. Now we have a deployment. You see that how many ready, how many up to date, how many available. Just wait for a few seconds and you see that you have deployed. So this is how you deploy it. So, but I'm going to use with the CRUD operations. So I created, I read it, I'm going to edit it. So edit again, replicas will be my favorite. So which is the deployment? This is the one, replicas, which is here. So I'll go for 10 replicas of what I want. Replications I'm doing it. And you see that you have a 10. You have one worker, the report, it's got created actually, but the reports which is coming one by one from the agent because of only one worker. See that? I got the 10 pods, but this time I want only 2. Why I want 2? Because I want to show you the controller also. So 2. And here you see that suddenly all the pod got terminated. So easy way. You can run 1000 also just within a second. You don't need too many skill sets to run these commands. And you see that I have a 2. First 2 is from the deployment. So now what to do? I think you know that I'm going to show you the controller feature. But before that, you know, I am going to tell you something else. I said very clearly deployment uses the replica set, and replica sets basically control the pod. So can I show you that? So get pods, get deploy. You see that, and I'm going to describe this one. So kubectl describe what? Deploy, which deploy? My deploy. And you see that you should study all the fields, get comfortable. Whether you understand or not understanding, please spend some time. Slowly you'll get comfortable with that. But right now, where is a replica set? So replica set, okay. If I go in opposite way, then you'll see that here it is a replica sets. Okay, so that means deployment is having replica set, and this is the name of the replica set. I'm going to describe the replica set. So RS and this one, and you see here replica set. Okay, this is the control by deployment. You see that control by deployment. And now if I show you the pod describe what? Pod, which pod? One of the pod of the deployment. And you see that controlled by CL. So you see the pod is controlled by replica set, and replica set is controlled by deployment. So that is how it happens. So now last feature of this one, get what? Get pods. And I'm going to delete this. Look at the age of the pod, guys. Age of the first two pod. This pod I'm deleting it. This pod I'm deleting it. And look at the magic. Controller, you have it here. And see, two pods got replaced with it. So desire versus actual. And plus many other features which we have. I'll insist you to try it out. This one, and this is deployment. Now, last API I'm going to teach you, it's called services. If you remember that, I'm talking about the services means it's a network load balancer. So what happens? Let's look at this. Let's understand some scenarios here. So let me create one scenario here. So this is your cluster, and this is your worker 1 and worker 2. So now you have one front-end pod running in this. Okay, front-end pod running in this, and then this. And after that, you have one back-end pod also running here and here. So theoretically, we say this is the front end and this is the back end. So now the question is, which pod will talk to this one or this one? Because you can't set the IP address here. It's a dynamic environment. The pod, you saw that pod is getting deleted, terminated. IP address will change. So what to do? So that is where you are going to introduce one service. What is service? It's a network load balancer. So now this pod will talk to this one, and this service will always load balance the healthy pod. This guy will decide whether it should be transferred to here or here. Theoretically, in short, did you understand that?
Mm-hmm.
All of you?
So do you want to repeat, Rajesh?
See here. This is the front end. This is the back end. Now, the problem here is which particular front end pod will talk to which back end, this one or this one, because you can't hardcode the IP address because it's a dynamic environment. The pod will get terminated and your load balancer, your traffic will not work. So what to do? So introduce the load balancer. In Kubernetes, we call it a service. So you always configure with the service which is have a fixed IP address, and service knows which pod it has to transfer the traffic. By the way, I'm not discussing the service in detail. To be honest, this is a whole day topic. What is service, how it works, what are the pros and cons, what are the types of service, each demo, it required at least a day of time. But right now, I'm just trying to give you the highlight at a high level so you can get a deep dive into that slowly. So service is a
So Rajesh, so load balancer is one of the service that you can leverage in Kubernetes to load the balance between the pod traffics.
I'll put it in this way. Service is a one API resources which do the network load balancing for the pod.
It's just the service name itself is called service, is that?
That's correct. Yes, that's correct.
Got it.
All of you understanding this?
Mm-hmm.
Okay, great. So now guys, I'm going to show you the demo for it. So how do we create a service? So actually, I don't know. So what I'll do? So kubectl service create. My bad. Create service -h. Now these are the types of service. I'm using the clustered IP by default. Now you will say, Rajesh, what is a clustered IP? External name, load balancer, node port. So right now I'm skipping it, but you need to know this is your task for you. So I'm using clustered IP, and this is the commands I'm stealing from this location, and I'm creating one service. Okay, load balancer basically. So what do you want? Kubernetes, create what service? What name was the name of the type of the service? Cluster IP, name of the service. Now this is the service IP address, which I can leave it as it is. My port is container port is running for this. My image is 80 port. So guys, I am running kubectl get svc. How many SVC we have? No, there's no SVC. There is one SVC you have because of this only API service is running, accessible. Okay, so there's no custom service I created. So can I create one service? So for this, I'm creating a service. And you see that get pods. Sorry, get SVC. Sorry, my bad. SVC. So see, this is the service. Now the question is how this service will load balance the pod. So actually, you know what? This is the service IP address, which is a fixed. The port number of service is this one. But right now, if I describe this service, it's not load balancing any pod. Let me show you. Describe SVC and see endpoints. You see that this field you have to check it out. So there's no port IP address. So what we do in this case? So in this case, you know what? This one selector labels of the service and the pod has to be matched. How do I do that? Let me do that. Get pods hyphen show labels and app nginx. So this two pod I want it, right? So this label. So go and edit the service. Nginx right now. So selector label, where is that? Nginx right now. Nginx, save it. Describe the to pod you got it. So basically what is happening, the how service works. So if the labels of pod matches with the selected label, those pod will be load balanced by service. And one more time, you will repeat this statement at least 20 times while practicing it. Again, I'm saying the labels of pod, if matches with the selector label of service, those pod will be load balanced by the service. It should be ready pod. So you see that right now I've just matched two, you got a two. Okay, so like that. So now if I hit, we see this is the hit. I'm hitting the service now, balance, and port number is 5678, right? Yeah. See here. I don't know which container is coming, but it's coming. See here. So one of these containers is coming. I'm showing you this output. You can put it up in a simple way also. Understood, guys, all of you? By the way, all this thing I showed you manually. There is a command actually for creating a service and linking the labels and all stuff like that. That is called expose command. Okay, so just I wanted to tell you how this load balancing works. For that I showed you manually, but expose command also you can use it. Okay.
So internally, so when you say I want a load balancing service, right, and you want to attach it to
pod.
The pod. So internally, it will spin off one Nginx load balancing server. Is that?
Yes. This is nothing but
Internally?
the network. It's not a server actually, you say. It's just like a routing happening at the proxy level. So don't take the service as a server or something. Service is like a network routing, and that function as like a load balancer on a network layer.
But that's nothing, the load balancing service, that is nothing to do with the Nginx. So it doesn't have an Nginx runtime.
No.
Built in.
It's a label actually here.
Okay.
Okay.
So basically, see the Kubernetes, runtime, right? It comes with the bare metal runtime. Rest everything you need to build on top of it.
That's correct.
Correct.
Bare metal is not right.
That's the approach.
You can install this on a VM also, and it's not a bare metal only.
But you will still only have the runtime. Then you build everything from the scratch, like namespace, pods, the services that are needed for the load balancing and all. Everything you need to build, from the scratch.
Yes.
You keep building layer over the layer.
Yes, admin will set up all this thing. So developers will only deploy the pod, and rest of the things will be managed by administrator.
Got it.
Just like AWS, they manage the entire infrastructure, and you go as an end user and create everything. It's like that.
Got it.
Okay, so now guys, this is a Kubernetes. Anyone have any questions so far?
No.
Okay, so now guys, Chandra, can you please stop the recording?
Yeah, sure.
So Rajesh, one thing what we want